right, you guys, Unit 3 was our statistics unit, where we talked about what were the three different, you had experiments, you had observational studies, and you had surveys, I think it was. Oh, hold on one second. And sample surveys, and where you just take samples of people. So all of these are different ideas. On the test, it does specifically ask you why something is a observation versus an experiment. And this question kind of gets into this in part B, where it talks about what treatment is being measured. But let's go ahead and start with A. Jamal observed vehicles passing through a stoplight to determine whether trucks or cars are more popular vehicles. Use the scenario to describe the following questions about Jamal's study. Identify which type of data collection was used. Explain your reasoning. So everyone did so well on this. This is, of course, an observational study. Because they're just observing something that is happening already. They're not changing anything. So below, when this is kind of a trick question, it says what treatment is being used. Well, no treatment is being used. A treatment is being used if it is an experiment where they make you do something, okay? So there is no treatment here. No treatment. I hope you're listening to this because you cannot read what I just wrote. No treatment. It's not an experiment. On the test, I think they do talk about treatments, and that's what would a treatment have been that we could have used for this if it was an experiment. We could have made the vehicles go a certain way, something that they wouldn't already have done, like you have to do this or you have to do this. You are giving the people in the experiment something to do that they might not otherwise have done, and that's how you know it's an experiment. Identify at least one source of bias in the study design. You guys were great. You came up with a bunch. One was like, where is the stoplight? Is it in a poorer part? Is it in a richer part of town? What time of the day was it? Were there a lot of vehicles going through? Were there not many? Maybe if it's in the middle of the day, you get a lot more trucks because they're delivering things. You guys had a lot of great ideas. This unit was really easy for you. So I don't see any problems on the test, but you just might want to go back and read through your notes about the different types of studies and things like that, okay? Oh, probability, the area under a curve is the probability. So if you have something that looks like this, you can still find the probability. A says, what's the probability that x is less than 3? Well, let's draw it out. When in doubt, draw it out. X is 3 is here. So x less than 3 is going to be anything in this golden triangle. Get it? Golden triangle. So what we're doing is we're just looking for the area of this triangle because that's going to be less than 3. So how high does it go up? Or if we redraw it over here, you guys know how to find the area of a triangle. Boom. There's your triangle. It's 3, obviously, x. This is the x-axis. X goes to 3. And how tall is it? 0.250. And it's a right triangle. So we just have to multiply these two sides together and divide by 2. So 0.25, you don't need that last 0, times 3. Oops, I ran out of room here. Times 3 divided by 2. I'm so sorry, it's ridiculous. Divided by 2, you probably already have the answer. Use your calculator. I'm going to try and do it in my head. This is 0.75 divided by 2 is going to be 0.3 something. I'm going to have to use it. 0.75 divided by 2. 0.375. Okay. Okay, so that is the probability, 37.5%. That x is going to be, oops, sorry you guys, that x is going to be less than 3. Find the probability that x is between 3 and 7. So we just need to find, can I switch my color here? We need to find the probability between 3 and 7. So the area, that's the area of this rectangle here plus this triangle. So the triangle is just going to be half of 0.25, which is 0.125. I just did that triangle in my head. So that's going to be, the triangle is going to be 0.125. And we're going to add on the area of this rectangle, which is 0.125 times 3. Just going to do that really quick. 0.125 times 3, just the width times the height, 0.375 plus 0.125 is 0.5, so plus 0.375 equals, it was just 0.5. So in between 3 and 7 is going to be 50%. Okay. Find the probability that x is equal to 7. So if we just go, let's see, let's do this highlighter one more time, like this green color. Go to 7, and it's 0.125. We just go straight up to the line and find that there. All right, and last question that didn't show up on this picture here, but it asks what is the mode and what is the median. So the mode is pretty easy to see, you guys. It is, let's see, I'll erase this stuff. The mode is the one that happens the most. Mode is the most. And that's going to be this one, which is 3. Okay, so that one happens right there. And then the median is going to be where you have 50% on each side. And if you do the math here, these end up to be 50%. And then this whole triangle ends up being 50%. So the median is going to be right at 4. Okay, so the mode will be 3. The median will be 4 because you have, the median means you have the same amount on each side. All right, you guys, for this one you needed your Z table. I think on the test they'll do everything in that like 95, 64, 95, 97% thing, and we'll try to get that up on the board for you guys to have access to that information, and maybe even just a big Z table. Whatever you guys need. You just can't use your own personal notes, but we'll get it up on the board for you. All the geometry classes at Lincoln High took the same final exam. The scores were normally distributed, which means it looks like a it's a terrible normal curve. That one's not much better. With a mean of 70.4 and a standard deviation of 0.9. So the mean and the median are the same on a normal curve. It's going to be here, 70.4. And every time you go one standard deviation, you add 9.6. Okay, so plus 9.6 would be what? 79, 80 would be the next one. Okay, so, but this next one wants to know the scores between 75 and 80. Now, if it wanted to know the scores between 70.4 and 80, we could have used one of those quick, like, what's the percentage between these type of deals. But 75 is kind of in the middle here, and we don't know exactly how much it is. So that means we have to find the z-score for both of these. Well, we already know the z-score for 80 is just going to be a straight up +1 because it's the first standard deviation. But the z-score for 75, we need to put it into our formula. So the z-score equals the score that we got, in this case 75, minus the mean, which in this case is 70.4, which is great. That'll give us a positive number. We know it's above the mean, so it's got to be positive, divided by 9.6, the standard deviation. Okay, so if you put all of this into your calculator, 75, oops, sorry guys, and we have 75 minus 70.4. Now, since I didn't put those in parentheses, I have to hit enter before I divide by 9.6. And I get like 0.47, so almost 0.5, like we were saying, but not quite. So 0.4796 2 if I round, equals 0.4792. Now what I need is a z-table, and since I don't have my paper copy, I just Googled one up. Okay, so here's an image of it, and it was 0.479, gosh darn it, 4792. So 0.479. I'm going to go with 0.08 over here. So about 68.44%. Okay, so that z-score is about 68.44%. And the z percentage for 1 exactly is going to be like 8413, 84.13%. And then to find in the middle, I just have to subtract them from each other. So 84.13 minus 68.44. 84.13 minus 68.44, I think it was, right? Approximately 15.69% are in between 75 and 80. So that would be this little bit here. Approximately, oh, let's put it up here. Approximately 15.69%. What is the probability that a randomly selected geometry student will receive a score less than 65? So again, we need to solve this z-score for, we just need to put in, instead of 75, 65 there. There we go. And so what we're looking for is wherever 65 is going to be over here, right? It's looking for the probability that a student will score less than that. So this one's not asking between anything. It's asking for everything below that 65%, which is exactly what the z-table gives us. The z-table gives us that left-hand side of a number. Okay, so we just find this 65 minus 70.4 divided by 9.6. So 65 minus, it's going to be negative, right? 70.4, divide that by 9.6, negative 0.5625, negative 0.5625. Let's look it up on our table. Negative, oh, I have the positive one over here. Where's the negative, do you think? Is this one negative? Oh, it is, but it's too small to see. That's all the positives. I guess I could pause this so you guys don't have to see me looking through all of this. Oh, look, here's one. Negative 0.56. About 28.77%. 0.5625. Yeah, so it's going to be this, about 28.77%. Approximately. Cool. And then what's the probability that a random selected geometry student would receive a score greater than 90? So we're looking for 90 over here, right? And the score on the z-table is going to give us everything. I'm so popular, you guys. I'm sorry about that. Is going to give us everything on this side. So if we find the z number, the percent that we want from the z-table for 90, we're going to have to subtract it for 100 because what we want is this side of the 90, right? And the z-table only gives us the yellow part, and we want this green part. So let's first of all find the z-score, and then look at the table and find the percentage for 90. So instead of 65, we're going to do this all again. Oops. For 9, well, I guess I'll just erase everything. For 90, so 90, it's going to be very positive, minus 70.4 divided by 9.6. And look, you guys, if I, oops, sorry. If I use the parentheses on my calculator, I can do it all at once. I do parenthesis 90 minus 70.4 divided by 9.6. okay? And I get about 2.04. I'm just going to hammer this home because you guys have been using calculators a lot, and I want you to understand. If I did this whole thing in there, but I didn't have the parentheses, I want to show you that I would get a different number because the calculator is going to do PEMDAS, right? He's going to do the order of operations. Where's my delete? Which means instead of subtracting first, they're going to divide first. So if I hit enter here, it'd be like 82.66. That's definitely not on our Z table. So just make sure that you are using your calculator correctly. So 2.04 is the Z score, 2.04. So let's look at our table. Oh, now we've got to go back up to the positive numbers. Good Lord. I hope you have your Z table right in front of you. It'd be so much easier. Oh, there's the negative numbers. So I'm going to find 2.04. So 2.001, 2, 3, 4. 0.9793. And that's going to be all that yellow, right? So that is, oh, where'd that come from? That's the actual answer, I think. 0.9793, so 97.93%. And we subtract that from 100 to find that itty bitty green piece, and you get 2.07 approximately. I did that in my head, so please check. Percent, and that's the green color right there. We had to subtract it from the Z table. Okay? Oh my gosh, we're almost done. I think one more. Set of normally distributed values, blah, blah, blah. Find this. Okay, let me make this smaller for you guys. A set of normally distributed data values has a mean of 120 and a standard deviation of 6.4. Find the Z value that corresponds with the data of 112. So the Z value is the Z score, so we just use that same equation. So we're going to have 112 minus 120, the mean, all over 6.4, which is going to be what, negative 8 divided by 6.4 equals, let's see, negative 8 divided by 6.4, negative 1.25. Okay. And this one gives us our Z value, so it gives us 1.4, but it makes us want to find what score that is. So our X, our unknown, is going to be here, minus 120 all over 6.4. And it wants us to solve for X, so we multiply both sides by 6.4 times 6.4. They cancel here, right? So where are we at? 6.4 plus 6.4 times 1.4 times 1.4, 8.96. X minus 120. Then we're going to add 120 to each side. So this cancels. X is equal to 128.96. Would be this what you would have had to have scored to have gotten a Z value of 1.4. All right, you guys, I think that this was the last question that we had. I actually think I'm going to try to do one more question for you guys, like one on the test that might be hard if you remember about like, I think there's one on there like finding the percent of medicine that goes away. So I'm going to try to find a video to do about that really quick. Otherwise, have a great night. I see you tomorrow. Get some sleep, get some good eats for our final.